the situation, I guess. So, welcome. This is Meet the ISENs, a fun introductory event where you can learn about your faculty here and some potential research opportunities you may be interested in your time here. So, that is the point of this event here. We're supposed to be introducing ourselves as your instructors and researchers, so you know we are a personal level as well as professionally, to talk a little bit about what makes us people in addition to industrial engineers, in addition to being faculty and researchers. And then some of you are here to hear a little bit about research opportunities. Some of the faculty here will introduce general ideas for those as we go. There are a number of steps that you should be thinking about if you're interested in. Yeah, it's pretty bad, right? Should this somewhere different? Yeah. Okay. So a few steps to think about. So first of all, any licensed student is eligible to potentially be a student researcher. This is a great way to enrich your experience outside of the academic classroom. Engineering honor students, this is a requirement for graduation with EH distinction. We need 6 credit hours. The first step you are going to do with this is you discover your interest, and you then see the email addresses of faculty present here. Ask them on your email, when are your office hours? When can I come and talk to you about research? I'm interested in your work. Potentially joining lab meetings, which are very often invite new people to. The next thing you might do is volunteer to help with some of the activities going on, with that professor in that space. If you are interested in getting technical and elective credits for the engineering honors program, if you are getting your requirements done there, there is an application. There is a GPA requirement based on if you're trying to do for honors or regular for 91 research. Ask the IE academic advisors; they can give you the application and the info. That is not the thing. Another option is to work as an hourly student technician. So, so you can talk about that further with the advisors and the faculty you might be interested in working. And then finally, conducting the research, either getting research credit or potentially working with the faculty member. I would like to point out that in the lectures that this is Troy Brady, graduate researcher when I started, and as Dr. Troy Brady continued doing research with me through his PhD. So it can happen for any of you as well. And so each of these focus areas, some of them, some of you. Some attention to speaking in the evening. So you can see how thank you. This is a good situation. It's on. Maybe the beach. I'm in the advanced manufacturing track, like Dr. Felix was talking about. It is one of the research areas within the department. Sorry. Somebody should bring this to the IT committee chair. Thank you. Yes. Yeah, so like I was saying, I'm in the advanced manufacturing track, which is one of the 4 focus areas in the department.
I teach ISENs F23, that is the introductory manufacturing and engineering design course. I believe some of you are already taking the class with me this semester. In the past, I've also taught ISENs F23, that is the production systems engineering. So in terms of research, I am a material scientist by background, and we are a primarily experimental. So most of the things we do in our research group is studying materials phenomena in the context of manufacturing process. So those are some of the topics that you see there. We are interested in understanding how materials behave and deform and fail under process conditions. We are interested in quantifying and modeling friction in engineering applications. And we also develop some techniques. Imagine things like developing high-speed cameras that can take billion frames of capture billions of frames per second to understand fundamental material behavior. And more recently, we have been also developing industrial scale processes like steel and other metals, but with a very low energy and carbon footprint compared to the conventional manufacturing processes that are currently in use today. So when I'm not doing all of these things, you can typically find me at home. So little guys there. So just to keep within the time, if any of the topics sound interesting to you, please feel free to reach out. The email is very simple. First name and time edu. I have had many undergraduate students work on research with my group in the past, mostly before public time, not so much of the COVID, but a background of that activity going forward. And what I have seen, at least with my research, is the undergraduate research projects typically fall into two categories. One project category would be something related to prototyping and machine development, things like CNC machining, 3D printing, or developing large-scale machines. The other projects would include making some food measurements of food, using food techniques to understand behavior like seeing in that video there. So I think that is it. All of these require hands-on skills. So if that is your strength, please again reach out and thanks for your time. Yes.
You're missing on time. Our next Dr. Natimo, please. Very good. Look at this. I bet I had to share screen. I didn't, did I? I was telling that that's my first few classes. Here you go. Thank you. Yeah, not sure. So, simulation and application. Some application research for students, unfortunately, is and 200 last couple of years. So I know next start when I
So how files and so so thank you. Thank you.
Just saying.
My name is Jason Lee. I'm a professor at ISEN and research focus in data science and my training is data science. And I joined this department last year. So and I'm teaching ISEN 23 and teaching ISEN 15 this year this semester. And I also taught the ISEN 614. So those are really important quality control. And my research area in research focus is in data analysis and data control and application, especially advanced manufacturing processes and systems. So by advanced manufacturing process, I used to add in manufacturing and I'm also interested in manufacturing. And by the manufacturing system side, I've been working with like this the connected manufacturing production systems. All right. This kind of my research is like integrating engineering knowledge, mathematical model, statistical and machine learning approaches, and development new data science methods to resolve some issues in the education. So here's the five pillars of my research. So as you can see, the research topics are quite diverse. So first research topic is about sense of design and business topics, right? It's about the smart manufacturing production systems, and then so we extract information from like safety, right? So turns out methodologies. So how to topics statistical methods, but bottom two methods are efficient stuff. So they English stuff. So interprets the correct measure things information. If I try my research you go.
Okay, thank you. Yes, so my name is David Eckman. As the slides would say, I'm starting my third year here in the department. I in data science. Love myself in the more category. That's what in our department. For classes, I typically teach at the undergraduate level 355, the system simulation for the tech elective data analytics 13. On the research side, my research deals with simulation methodology. That is driving simulators, that is known artificial or augmented or virtual reality, not that fun kind of simulation I do, or discrete event simulations of statistics, optimization, a lot of computer programming. But what you'll see is I don't have the nice pictures that all the other professors have. What their research looks like. Right? It's a lot of math theory. So it's all about the use of simulation models for making decisions and what kind of algorithms can we design and analyze for the purposes of making those decisions. And outside of work, I spend time actually back in the first playing with my mom there, changing diapers, spending time with family. So that was my son there on that picture. He turns me into So baking a cake or something to make sure. One for him to smash. Next slide. Okay, so as I mentioned, research sort of has one of the prerequisites skills. Our class is computer programming, so it's a little difficult to engage with undergraduate research. But what I found first is have students assessing open source white memory that I have assembled. It is a collection of simulation elements. So it's easy to carve out a piece for students to work on if you're looking for see probably statistics apply in interesting settings, work on chains, things like that. There is probably a year that we can find. And that's the best I can do in terms of colorful points. Thank you.
You're right. So that see yeah, thank you. Yeah, that's right. So my name is Nicholas and here for 8 years. I'm actually saying citation should be the operation of one, and then session so in the research about things examples are basically essentially learning that it's a beard that we have right. Like it's really like and then after it's signing and from it's in the exact optimization elements from the midpoint, so I should sort exactly the system equations that are used to sort of consider practice. When I like it's probably I think it's very hard. This is from charts. So the pictures that I do. This is my system chapter. So it's a picture there. Yeah. And I can from have to go to other events like things like that. This is my friendly. So first I learned this is how I like to picture my kids. So that person at least there in that picture. Yes, and then this also with my the students that are graduated. Also, with the 6 months of college, was down 5, like my presentations, etc. And then this here graduated with COVID. So we have no graduation. So it's a big thing of COVID you can see there. And here I was able to go to a conference next to this day, and we took a picture there in Star Wars. Our entire session coming up later to him, and that way the person that is time for the very outside, and they did booking your thing. Yeah, that's so. Okay, so this is what I like to do some tricks. I like to students play something with me. Even sport that I did consistent before, like volleyball here, and then that line. Then I like soccer against private students, and then basketball, and even something that is called pickleball. So each child you have a vinegar, bunch of vinegar. And do that. So very interesting stuff. We just keep talking, see so say sorry to hearing you. We would love to have a good time with you here. Thank you. So we have Andreas, who is representing Dr. Group. Thank you very much, Andreas. Thank you. Hello, everyone. So we say a few words about research.
We are in the advanced manufacturing track, with the in situ monitoring for advanced manufacturing technologies in order to see what is happening in the material part and in terms of defects and materials properties, and correct them and predict them in situ, meaning when the part is being made. So we currently investigate currently in 3 manufacturing processes. The metal additive manufacturing, 3D printing. So the second one is 3D printing of small polymeric materials, and the third one is small polishing of cells, spherical cells that are used as fusion, nuclear fusion fuels. And this process takes a lot of factors days maybe, and it needs to be in case drugs and defects. So the modeling part, we deploy multiple sensors that are fused in the machines and collect data from the machines in order, and these are then processed and used as for predictive machine learning and deep learning in order to predict the material property and process. Models are 25 and 17. So yeah, you can reach out the problem it's just an agency, it's an experience. So when the questions, reach out to you. Yeah, the rest, right? Thank you, Andres. Thank you. Next up, we have skills, please. Okay, good. I can talk. Anyway, so Dr. JP and I are both great. I said writing is student success. JP is going to talk to you about something the other part to do, but I'm committed to students. So we do present day, internship, or applications, with interview preparation. And the is very extensive. We have significant expertise. And outside of the 2000 context of LinkedIn, investors are in +% of former students. So if you're interested in the company, and you have the tracks that I can connect you, and I see that get some kind of back there smiling and nodding affirmative because we have worked together for a couple of things. Okay. So thank you. And we're up at 18 and 30. Don't mind, reach out to us. Thank you. Share time with us, so we gotta know. Please come. Thank you so much. Yes. Somebody faces Dr. Sasani, my students call me Dr. S for short. That's completely fine. I have the pleasure of directing we have some previous lab members, current lab members in the audience. What we do is in factors engineering, specifically in healthcare. So if you're interested in application of human factors or systems in healthcare, that's what we do. Now, all of that's around the data science and computer science. So creating applications. Telling the system, so device type of system, looking factors, needs, and issues. So if you're interested in those things, please come talk to me later. Research, just figure out what's going on. I'd be interested just what we can.
or talk to our students. Some of the signature projects are hyper student mental design technologies to detect high stress, high anxiety, and help students self-manage. We combat veterans with PTSD, with some sort of anxiety, PTSD detection, and time, and self-management of that. We have various projects with hospitals. So we take things like hypoglycemia, which is sugar, tension, which is like pressure. So one of the medical applications that we're really interested in, not just the human factors part of it, but also sensors and detecting something meaningful, which is the data, the big data type of application, a lot of machine learning and AI nowadays to detect something meaningful pattern is big data. I teach ISEN 330, so I've seen a lot of you already. Some in Greece, some here in the station. But as a teacher next spring, teaching this semester, and this summer teach the same course in France. It's really diverse study abroad experience. Look up on the website. Please, either take ISEN 330 here, that'd be wonderful. But it would be nice to look at the study abroad and talk to previous students who've taken it. Can you raise your hand? There are many students on campus who've taken study abroad, especially 330 to make sure you have that experience. It's a wonderful experience. Thank you very much. Thank you. Thank you.
We're actually staying on time. I think we'll keep it. Okay. That's kind of weird.
Okay, I'm Chuck Meyer, and I've been here since 1983. So I got my PhD here. I keep the Air Force Laboratories in Patterson. I started a lab in AI and said, "No, you got to have a PhD," which I couldn't understand. So I got money. I could hire PhDs. They said, "No, you have to have your." So I came here. I'm directed Space Systems Laboratory here at ABM until 97. And associate professor in this department. Then I was also in a company, and I said, okay, there's so much money going around. So I was on my tenure, and I now am an adjunct professor. I teach the system engineering courses. I used to teach an AI course as well. But right now, he's keeping me busy enough. Mostly I teach 641. Which is a system engineering methods course, how to do system engineering. But this semester, they gave me the opportunity to do the general course at the N640, which is systems thinking and analysis. Those are graduate courses. And quite frankly, when I do have undergraduates that come and take the course, they do better than graduate students. So, because they like to work. My current research, I do any research at the university, but my company, Space Systems, does research in AI methods and system engineering methods. But the AI stuff is pretty interesting. I played video games for a bit. And so the Navy pays me to play StarCraft 2. So I built AI models that compete with humans, and the basic idea is to build minimalistic agents, because you're training soldiers. You don't play at the top, you play something that's like the enemy. I'm also doing work in just getting started in the what we call semantic OCR, which is reading scan reports and kicking activating within an enterprise. I do a lot of work in what's called natural language understanding, which is very different from natural language processing. text that you can do criminal work in what's called cybersecurity assessments. If you're flying an F-35, if you're flying a college station, probably not. If you're flying enemy territory, there's people trying to hack into your systems, turn your weapon systems, disable your guidance, and so forth. So we have to the what's called the PID, process IT, on the platforms, and identify where vulnerabilities come up. And then one of the interesting areas, my background undergraduate in math and physics. Then I decided I'm going to get married. They said, well, then you better study construction engineering, get a job. So, so that there's an emerging discipline applied what's called QP to modeling of how humans understand and make decisions. Okay, so you can take into account effects. My classic example is, you know, my wife and I have a race train experience, and you know, I walk up to somebody in the and say, "Hey, Joe, how you doing?" Right? Because doing pretty good, you know. But if I and I say something else, I say, "Okay, Joe, last time you had a date, it's been a month." Or if I do, it's been a month since Joe's had a date, and I walk up first and say, "Joe, how long has it been since you've been out? See you now, taking a room." So how you doing? You're going to get a different answer, and that difference can be predicted by the performance. So it's very interesting. Slide. So this is a picture of the ice rink. Graduate research opportunities in AI and systems engineering. Okay, so things you can do that. Background in tensor calculus. It's that it's pretty straightforward. Speech to text. So it's for being able to talk into a microphone and actually have the voice corrected and so forth. All different ways. It's transfer learning methods. So which AI corporations, which corporations like the Alphabet and Microsoft have trained, then they've trained with tens of thousands of GPUs, right? Stuff you couldn't really do. But you can take those and on a fairly system, we target them for your application. It's very interesting technique. Big problem with explaining AI, right? So you're using the machine learning. That's great. You know very well, but it cannot explain, you know, keep the answer. Okay, and so sometimes the answer that the humans is the explanation for the answer you gave. So that's a very area of research. AI ethics and fairness, right? So they're big talk right now. You tell your students to use ChatGPT for science. Okay, you know, ChatGPT. I know some China, right? I'll give you a summary of undergraduate search topics in AI. Okay, so there's some editing and I put English on it, but that's basically generated by ChatGPT, and it's its database now. So the system. So anyway, there's the people here in your department who are very proficient at training in these methods. For a couple of days, I don't see W1. So one of the athletics classes are going to be good as well. System engineering, just about anything in simulation, in management, right? So we talked about the cyber how do you design mitigations in platform IT so that it can take ahead and keep on flying. The adaptive system combines system engineering with a, so you've got an aircraft, right? And it takes a hit, it's control surfaces. How do you embody it with a control surface that can relearn the aerodynamics and get the aircraft coming? And of course, with water-based systems engineering, that's a big issue in a big area of search. So I appreciate that. So just the ice rink, the ice rink is like Thursday nights. That's our 2 foot. So
Excellent. Great. Well, okay. Next up, we have Dr. Murray Craig. Very good.
Now for something. Howdy. So I'm very different. I'm not your typical professor. So I'm professor practice. Who's had a professor practice? So we're individuals who have spent their life in the community, spent their life in different areas. In my case, I spent 30 years in NASA, 24 years in the Army. I found those remember laughing. One of my students looked at that and thought I thought him too. Sounds like a number straight to the heart too. So while I was at NASA, I flew for shuttle missions, 1,000 hours in space, and then I spent 10 years in safety. As I said, I'm an aviator in the Army, 4,000 hours rotary, fixed line jets. So pretty much flown everything from treetop into going up there into space. So, a little bit about me. I think because of my background, I'm a thrill seeker, and I'm an animal. So it's my husband and I with our 2 dogs, Shadow and Whippet, my granddaughter Cubby. For those of you that saw me in the spring and saw me running around with a broken leg, that would be the offender right there, maybe. But what a sweet face. It was a total accident. I still remember. This guy is really famous. He's earned over $250,000 in his career. I attribute $5,000 to that for me. And then I do things like propel down the Olympic. This is the Olympic cracker that was I highly recommend. It's about 100 kilometers an hour with your face 2 inches off the end. It's really, really fun. So let's get to the serious stuff. Next slide. All right, research interest, because of my background again, very first one, spacecraft occupant protection. When I flew the shuttle, come back and lands like an airliner during benign landing. Now we fly in capsules, and every landing is an arrival. Every landing is a dynamic impact event, and it's also been just think of if you drive up to your driveway every day, you pull your car into the driveway or into the garage. If you had some probability of having an accident every single time you did that, that would be a good thing. So we want to protect our crew members during nominal operations. So we do computation modeling. We used to use finite element models of if you work with test dummies. Now we use finite element models of humans that were based on cadaveric data. So very, very interesting. And I tie into that if we could go to the next from there. Thanks. Aerospace human systems integration, human robot multi-agent interaction. This is where you get to be both test subject and PI, because I was the only one who could fit in that suit. And then another one of my areas is safety and reliability engineering. So right now we are looking at the leading causes of general aviation accidents. So the leading cause is control. Number 2 cause is thrust. And we've made tremendous progress over the summer. I brought in 2 students, one undergraduate and master's. The undergraduate student, I got bragging, he is performing at I haven't seen that in PhD candidates. And we have made so much progress going through the NTSB database using natural language processing, using some really innovative algorithms students. We did reach out to computer science professors. They're like, they're way ahead of our idea at this point, which is a little scary and I guess a compliment. But I attribute that to the students. So we have students in the lab from undergraduate to PhD. So if you're interested, you know, area of stuff. I am also the director of the Texas A&M Space Institute as of a couple of days ago. And so I keep busy with that. Courses that I teach in the design, system design. Tom and I created that class a few years ago. We tag team on that. And then my other course is system reliability analysis, quantitative risk analysis, and human factors for aerospace environments, which is cross-listed between ISEN and Aero. So you have taken that course, and it's a really great course because you get to work with Aero counterparts and see their perspective on it. But from factors perspective.
Maybe some. Thank you. Yes. I'd like to. Dr. Plummy, you can slide, or they can share full president. Okay, I know what happened here. Hang on. Oh, no. Okay. Start with you. What did I miss it?
The ISENs.
Oh, it starts with the next. That's okay. Yeah, there. Thank you. Actually, good. Thank you. How's everyone doing? Yeah. All right. So my name is Adam Yan. I'm the professor of research group back in 2018. I teach a lesson 20 in ISENs F23, which is programming, and ISENs F25, which is organization. My research is in the interplay between organization. I'm particularly interested in applications related to health and healthcare. Next few slides. Before that, my main hobbies are spending time with family and friends, shopping, hiking, and I'm a drug junkie, so I'm an extreme fan. To remember some of the research, I'm going to very briefly projects that I've been working on. Is on data optimization for mitigating crisis, specifically for university campuses. I'm collaborating with the time and the accounts for service that's kind of and the main idea that we have two main objectives is access to the services. Trying this can be predictive rates and optimization methods some access, specifically personal to students. We're also interested in student articles, essentially reports indicating the progress of the students as they were treated with to identify treatment plan effective. So this product is really pretty good. It's been a big impact for me, and we're looking to try to next project is going to be optimizing spatial response. That's basically it's like the main idea is the benefit of the first so we have tons of data. So if you put this data to the earth and generate population to construct spread capture strategy is mitigation strategy specific screen vaccination is going to that sounds very technical, but very good application specifically when you're starting using these to characterize materials in a very high actually the application gives a very strategies. This is another show. I'm taking questions. It's great. Yeah, this is awesome. Where I am a bit. Okay. Thank you, Dr. Flood.
Thank you, Dr. Ferris and Lodi. Okay, my name is Ray. I joined this department 5 years ago, faculty member. In data science area, I teach virtual courses, undergraduate courses, design analysis of experience, and some lessons 14 and we have graduate level course, some lessons 16, and besides that, I some teach lesson 619, which is math machine learning course, and this semester I'm some teach ability course, lesson 609, and master general side. Data science, general machine learning, and particularly analysis for computer simulations and other areas of certification, classical statistical methods. Okay, so talk about my research, major research interest focus on data science for computer simulations. So basically, incredibly analysis of complex computer simulation model, for example, finite element model. If you want to optimize that model, so you have to some design experiment and collect the data. Like you have three-dimensional input points, like a input dimensions, and you find which location, like which configuration put variables to best define. So that's why we basically collect a bunch of data and kind of machine learning estimate that you can predict and points you have computer simulation and capitalism. Certain qualification that we can use probabilistic to kind of emulate certainty, tracks of certainty in try. That's kind of research and interesting. So things that totally just totally. Thank you.
Thanks, Dr. Display if you're ready. Yeah. Okay. They don't have any pictures in
my main area is the application of research to supply chain logistics. And so supply chain determine where to put inventory and how to run with the customers. So I teach 3-7, which is the production system. I think it's called. I've taught them when I teach a supply chain course. So, some of the things I work on are kind of various. They're just driven by things that either frustrate me or observation we make my business. So, for example, they just finished the paper and they just got accepted that I'd like to call Jimmy Jones. So they send bicycles, these sandwiches. And so imagine that they're extremely fast. And so the fastest you can do it is like every order that is placed gets some bicycles straight to the customer and comes back, right? But then you have to hire the bicycles, right? Like bicycles out there straight. On the other hand, you make your plates to the next door. Then one person can make a round of 2 drop-ins. It's much more efficient and cost effective. But the people who make the sandwiches have to wait. And maybe the demand that Jimmy Jones see function. Okay. And so there's this trade-off between maximizing revenue, which can do a huge number of bicycles and straight back, or
at the cost of making improvements as efficient as possible that you could accomplish with just a few bicycles to the brain and the liver, say 10 seconds. And so we create the band and the function delivered the data, right? And the constant of the delivery routing codes, and it determines the number of words to batch together in the delivery to give you the same channels that hopefully of course it applies than just jigging difference because companies like Amazon these days is trying to it's very good cities and they have dependent the research required to guarantee delivery target to customers. And so they face the same kind of trade. The faster we get the revenue we can generate, and I'm getting a stop, but I don't care about it. Thank you.
Give me a second.
That's my family. My last name and Tamu that that's the challenge. GEUNS.
Sorry, there it is. Great. Thank you again, Dr. June. It's all right. Good news. Next. This guy. Okay. Here I am, Dr. Ferris. This is me. Everybody know me. Start the clock. Great. So I'm an associate professor. I've been here since 2011. I'm a proud Texan now in my life, given that 13 years of my life are here. I'm in the Health and Human Systems Engineering area. I teach 330, 435, which I'm teaching right now. Anything to do with humans interfacing with things in a system. And that also describes my research interests. So take a human, put him in a system and support that human. We need to have effective displays and controllers that it generally defines what we're looking for. Increasingly with really cool systems like human robot interaction systems. And these are some of my personal things and people I love the most, my family, my cat Cleo that does me here. And I'm a disc golfer and a husband. So I'm a musician. So I have a light guitar. I may show you at some point if you ask nicely. I'm also I like to call myself a light smith. Also, so as a hobbyist, I like to make things, with Arduino microcontrollers and various elements. Interested in research in the lab in the human factors and cognitive systems laboratory. So 3 general areas that we look for help. We have some simulation that people can get into. So coding for our simulators. We have a driving simulator. We're working in a flight simulator. So working with it this fall. We build displays and controllers. We design in our simulation environments to test them. We measure humans. We are also interested in human sensing. So we're collecting physiological data and we're trying to make sense of the human cognitive state. Are they under stress? Are they having, can they handle it? In particular, I like to build things in my lab. So I'm looking for people who like to build hardware or software. And gadgety things are interesting to me for reasons beyond research. Also, you can see me bring the light cape during my lectures up there. Phone today, tell you. Thank you, Dr. Zahavi. I'm sorry. Maybe you can work on shut.
Howdy. My name is Mariam Zahavi. I'm assistant professor in the department. I'm also in the Health and Human Systems Engineering group. In undergraduate courses, I teach ISEN 330. A couple of years back, I taught ISEN 210. My research areas is mainly on human performance modeling and with application with surface transportation and assistive technologies. You can see some of the projects that we have been doing, and I will talk about some of them right now. How many of you have been in a police vehicle? Fortunately, no one. That's a good news, but I have been a number of times, and my students have been a number of times as well. So one of the research areas that we are interested in is how we can improve the design of in-vehicle technologies for law enforcement. Okay, and if you have ever been in a police vehicle, you see that there's a computer that they're working on. There is, for example, their cell phone. They have multiple cell phones for different purposes, and they're using radio, radar, and what we have observed is that causes a lot of distraction. That causes a lot of mental overload for them. So in one of our projects, we are trying to build a machine learning algorithm that can in real time predicts the amount of workload that they are under at each point, and then the system adapts itself to the amount of workload that they're under. So they can be a low clutter display, that can be a high clutter display, depending on the amount of workload. So if you are interested in seeing an application of data science and human factors, that's something that this type of project provides to you. And the other project I have is in the field of assistive technologies. I work with people from biomedical science and also from computer science. We are designing upper limb prosthetic devices for people who have amputation, and we are developing algorithms in a way to be using these devices to reduce, again, their cognitive load. Because one of the problems with these devices, not only that they're heavy, sometimes they have reduced usability. And the reason for that is that it's very challenging to use those arms. They have to use the residual muscles on their upper arm to control several degrees of freedom in their arm. And that can be a very cognitively demanding task. So if you're interested in, this assistive technology application, this is just some of the examples of the projects, again, we're doing. So anything from design to simulation to data analysis, my lab is involved in all of these steps. And I have a number of undergraduate students working with my PhD students and postdocs. So contact me if you're interested in. My email is up there. Thank you.
Dr. Elizondo, new ISEN faculty member. Come on down, please. Welcome. Okay. Yeah, I have slides for you.
Everyone, as I mentioned, I'm Dr. Jay Hill. I've been here for 30 days. I'm teaching the writing courses, the writing student success and so we're at ISEN 30. I'll be teaching you there, and then capstone ISEN courses, the presentations. Side of that, the topics. Just kind of look down, try and like that's like it's fun research. It's objection. PhD mechanical. So it's also next slide, writing and communication. So we can have needs to presentation, anything like that. Professional stuff. So part of the job. Extensive. So our internship is round there to be advised this meeting was not happening. So that's all day. That's what I am changing. So let's make sure we're there.
Very last, but very much not least, we have Dr. Sean. Welcome, Dr. Sean. So glad to have you here. So there it is. All right. And then we're going to be rapidly shoved out of here because there's another class coming in. So before that happens, thank you all for being here. By the way, we're recording this. We will have the link available on YouTube at some point in the future after we clean it up a little bit. So thanks, Dr. Sean. And peace. I'll be here. So, Shishyan, I just joined this department as well. So, you're here. The system professor, maybe working operations research. This semester, I'm teaching 320. Very important for operations research, and research is mainly focused on occupation, not only for but data science, systems engineering, as well as the student application. And that is my personal page. You can find more information on that. Because I work, I like watching sports, listening to music. I play, but not very good at those. But right now I have 2 cats, so that's maybe my things outside the market. So the first area of my research is about energy systems. As you can see, we have a lot of uncertainties in these areas, in these systems. We have sun, we have wind, we have possible contingencies like power events that cause disturbance to the system. So we have resiliency over decision, and the system on a very large scale, it has very complicated nonlinear constraints on the decisions. But it has huge economic and environmental impact. So to find good decisions about these systems. And if you like data or high performance computing, to talk. Another part of my research is about algorithms, geometry, and algebra. So have you ever thought about this question in your life? How many parts can you put inside a box? How many disks do you need to cover a square? And these turn out to be highly related to analysis about algorithmic performances. Understanding these questions can help us to estimate the performance of certain algorithms. How many points does the intersection of the curve and plane have? It actually has some suggestion of clarification on problems. These are very interesting mathematical questions. If you ever wonder about the math behind algorithms, that's it. That's my presentation. That's it, folks. Thank you for joining us. Enjoy the rest of the meeting. Thanks for attending. Thank you.